Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dopo Jr., your math tutor. And in my today's lesson, we are going to continue with system of linear equations in two variables. So under system of linear equations in two variables, we want to be looking at solving system of equations by graphing and looking at some word problems. So this is the first word problem that I want to look at. The problem says James and Peter take long walks every evening. James walks at a constant speed of 2 kilometers per hour, and Peter walks at a constant speed of 3 kilometers per hour. One evening, James headed out first and had already gone 2 kilometers when Peter started his walk. When they have walked the same distance, how far will they have? Let me correct this. Will they each, okay. How far will they each have walked? It looks, it may seem to be somehow off, but it's correct. So we say, how far will they each walk? Or will they each have walked? Or better still, you could say, how far will each of them walk? Now, so the first thing we need to identify here is what is the problem requesting us for? At the end of the problem, they say how far has to do with distance, right? And we are discussing kilometer for distance. And we know that distance is in relationship with time. So a distance is covered with respect to time. So when there is no time, then no distance have been covered. So the first variable that we need to identify is our time. So we can say let x equals time. So we can say time taken in hours. So x represents the time taken in hours. And then the next variable we could bring in is y, and then we'll say the distance. The distance in kilometer. So these are the two variables within the problem. So we are talking about hours, the time that it took them to cover a particular distance. So let's go back to the problem and try to identify some of the things that were given. James and Peter. So we are discussing two persons right here, James and Peter. So let's start with James. James and Peter take long walks every evening. James walks at a constant speed of 2 kilometers per hour. So we know that from our elementary days, we know that speed is equal to distance all over time. Speed is equal to distance over time. So we could just represent this to be S. We say D over time, right? So what would be the distance? So D now should be equal to S times T. So you see, we have 2 kilometers. James walks at a constant speed. So his speed is 2 kilometers per hour. So the time is unknown. So we know that time here is X. And the kilometer, which is the speed, is equal to S. So we have the distance now to be 2 kilometers times the time, which is X. So it's 2X. So that's the first distance James covered, 2 kilometers per hour. Right? That is James first. So we will do the same for Peter. And Peter walks at a constant speed of 3 kilometers per hour. So again, for Peter, we could say speed equals to distance all over time. So his distance now should be the speed times the time. So his distance now will be 3 kilometers, which is 3, times X, because we don't know the number of hours. We don't know the number of hours that he actually walked for. But we know that he walked for 3 kilometers per hour. So we say 3 times X. X is representing time. 3 is representing the speed that he took. So if he walked for like 1 hour, then we say 3 times 1. 2 hours, 3 times 2, and so forth. Then we'll determine the distance that he actually covered. So let's continue the problem. One evening, James headed out first and had already gone 2 kilometers. This one, there is no per hour to it. So it means that the distance, this one, it represented distance. They said, and had already gone 2 kilometers. They did not say he had a speed. No, they said he had already gone 2 kilometers. So it means the distance, his additional distance was just equal to 2 kilometers. So we can add X to this one because it is not the speed, it is just equals to the distance. And then we continue. When Peter started his walk, okay, James headed out first and had already gone 2 kilometers when Peter started his walk. So they did not say anything about Peter. No, nothing else was said about Peter. Whether he covered an additional distance or he did not cover any distance, they did not say anything about Peter. So we are only considering the first the first speed or the first distance that Peter had, which was 3 kilometers per hour. That's exactly what we're considering. So when they have walked the same distance, so this is James' total distance, 2x plus 2. So they said they have walked the same distance. So this James' total distance, we could say, since we said that y is equal to the distance in kilometer, we say, okay, let y be equals to James' total distance covered. But they are also saying that when they have walked the same distance, so it means that the two of them, their total distance is equals to y, the same distance. So if James total distance here is y, which is 2x plus 2, Peter total distance will also be equal to y. So we say this is y equals 3x. So therefore, we have a system of linear equations. These are the two equations now that we have. So we want to use those equations now to find a solution by graphing. Because they said we should graph. They did not say we should solve. But what I'm going to do is that I'm going to graph it, and I will also solve it so that we verify our answer. So again, to graph the first equation, y equals to 2x plus 2. Now the equation is in the form mx plus b. So it means our y-intercept, which is just equal to b, will just be 2. This is our y-intercept, 2. But the point, y-intercept means x is 0 and then y is 2. That's y-intercept, right? So this is our first point. And then what is the slope? The slope here is 2. So the slope m is equals to 2. So that's for the first equation. The second equation, y equals to 3x. So this is in the form of y equals to mx plus b. Now, so our slope is equal to 3. So we can say this is 2 over 1. And then we say 3 over 1, right? And then our y-intercept, this is 3x plus 0. So y-intercept will be equal to 0. That is, if x is 0, y will also be 0. So y-intercept will just be 0, 0. So now let's plot. Let's graph. Let's graph this thing. Let's graph it. Let's graph it. Okay, so what's the first one? When x is 0, y is 2. So y is 2. So we have 1, you have 2. So 2 is right here. And then the next, the slope. From this point 2, they said we must move 2 units in the y direction, the positive y direction. So 1, 2. So we'll move 2 units in the positive y direction. So let me see how best I can. So that okay. 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 So remember now that this is the this is the x-axis. This is the y-axis. So it's a y-axis. So that's the first one. So they say from this point 2, we should move 2 units. So we have 1, 2 units, and then 1 unit in the x direction, 1 unit. So it means we can connect this guy like this. So we can further extend this. We can extend this. But let's do the next one. The next one says 0, 0. So it's right here, right? When x is 0, y is 0. And then the slope. So from this 0 now we move 3 units in the y direction because there's 3 over 1. So it's 1, 2, 3. 3 units right here. And then we move 1 unit in the x direction. 1. So we can connect this one like this. So we have to run this line. We have to run this line. So let's see how we can do it. I don't know as to whether it might be like this, something like this. Gosh, it just be something like this. Sorry that the line will not be straight because this thing is not, the boxes are not actually straight. But at least it should connect all of these intersections. So now, what else? 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 So we also move this. You see, 1, 2, 3, 4, 5, 6. So we also connect this one as well. Connect it like this. I think it should be like this. No, sorry. This should connect it like this. This should actually meet right at this point. And what is that point? What is that particular point? So we have when x is, okay, 1, 2, 3, 4, 5, 6. So when x is, I should have drawn this thing correctly. So when x is 1, 2, 3, when x is 3, then we have y to be 6. 1, 2, 3, 1, 2, 3, 4, 5, 6, 6. Y 6. So there's a solution. The solution is just 3, 6. The the graph, the lines are, they're actually straight lines, but because of the way in which I drew the lines, so that's why we are experiencing it like that. The boxes are not really square. What if we were to prove it? Take the two equations: y equals to 2x plus 2, and the next equation, y equals to 3x. So we can use substitution. We say there's equation number 2 and there's equation number 1. So we can take equation 2 and put it within equation 1. So that is, where's where we see this y, we're going to put 3x. So we put 3x equals, this is 2x plus 2. Then we solve for x. So this is 3x. You send this 2x across the equal sign. What do we get? We get minus 2x equals to 2. So what will we have? 3x minus 2x is just equals to x, equals to 2. So this should actually be 2. Yes, this should actually be 2. So like that's why I said the graph. We have to redraw, resketch this graph. This should actually be 2. So if we were to do the next one, we take the second equation or the first equation, 3 times 3x. So y is equals to 3 times 2. So this is just equals to 6. So we have 2, 6. So what I'm going to do, I'm going to take my time to sketch this graph so that we have a picture of what we are doing. So let me take my time to sketch it. Okay. So I'm going to do it like this. Sketch it like this. Okay, so we know there's 2 and 6. Okay, so I'm going to sketch it like this. I'm going to take my time to sketch it like this. Okay. Okay, so let me continue on this side. Let me continue. Okay. Okay, so Okay, so we're going to just use this one now. So let's say this is the graph. Let's say this is the coordinate system. And I'm going to take it from this point. Okay, let's say this is the coordinate system. There's X, there's Y. So let's plot now. Let's plot. Yes, let's plot. Now, the first equation was y equals to 2x plus 2. So when x is 0, y is 2. So when x is 0, now this is 0, this is 1, 2, 3, 4, this is 1, 2, 3, 4, 5, 6. This is -1, -2. This is -1, -2, and so forth. So when x is 0, let's do it now. When x is 0, y is 2. When x is 0, y is 2. So we move 1, 2 units right there. Then we come to the slope. When y, the change in y now, change in y is 2. So we must move 2 units in the y direction. So it's like 1 and 2. And then we move 1 unit in the x direction, 1. Right? So connect this one like this. This is this. Okay. I think it may rather give us some tough times because of okay. So what next? So there's the first equation. Let's move to the second equation. So I'm just going to. So the second equation says when x is 0, y is 0. When x is 0, y is 0, right there, right at this point. And then the slope. So we move 3 units, 1, 2, and 3, right there. And then we move 1 unit in the x direction, 1. So we connect this like this, just like this. Okay. So now we have to run the 2 lines. So we know that they will intersect. They will intersect. The 2 lines will intersect, right? So we have to run the 2 lines. So this guy goes like this. This guy goes like this. Okay. Still, it's not it's not really perfect. So this other guy goes like this as well. Goes like this. Okay, great. So it must intersect right here. Right there. Yeah. So you see that is it. Honestly, that is it. Yeah. So that's the 2 of them. So where now do they intersect? Right here. So we see when x is 2, y is 6. So right there. This x is 2, y is 6. So if you have a graph paper, you can do that correctly, and you will notice that right at this point, this is a point at which you see that the two graphs intersect. So where the 2 graphs or the 2 lines, since this is a linear equation, where the 2 lines meet, that's exactly the point we refer to as a solution set to the system of equation. So thanks ever so much for watching. See you when I see you.